Welcome to Mr. Tompkins Ed Tech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers transformations of curves. I've taken related questions from my past paper walkthroughs and given them to you here back to back. This series is intended for the last few weeks of your revision, and my advice is to go through all the practice papers and past papers before you look at these, or the compilation videos will be the mathematical equivalent of endgame spoilers for you. Having already worked through all the practice papers, these compilation videos will give you a deep dive on topics you are still finding challenging, give you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Question 26. The graph of the equation y equals x squared is translated by the vector 2, 0. Circle the equation of the translated graph. Okay, well, the vector 2, 0, if you remember rightly, this is the x1 and this is the y1. So 2, 0 is 2 units to the right. So we're taking our graph of y equals x squared, which is our kind of standard parabola, and we're shifting it 2 points to the right. So this point here will now be 2 units that way. So looks the same, just shifted along a bit like that. That's hopelessly drawn, but anyway. So it is a translation of 2 units in the direction of x. Now, if you know your translations, and you should, you know that that should be, we take our function of x and we translate it by taking 2 off the values of x. So, where we see x, we need to replace it with x minus 2. Now, in the case of this quadratic y equals x squared, that means we're going to go to y is equal to x minus 2 all squared, so it's that one. A lot of explaining for 1 mark, but you kind of have to know it in order to get that 1 mark. Okay, so we've been given the curve of y equals sine x, and we've been asked to sketch on the graph the equation y equals sine x minus 1, which is just a transformation of our original graph. So basically, if you take a graph y is equal to f of x and you translate that into a graph y equals f of x minus 1, then basically what you're doing is you are doing a translation of 1 unit, well, negative 1 unit in the direction of y. So that would be minus 1 unit. So we're going to go 1 unit down basically. So every point on this curve is going to be 1 unit lower on the graph y equals sine x minus 1. So let's take all the points on our curve that we can easily find the coordinates for. So we've got a coordinate at 0, 0. That's going to move 1 point down, so it's going to be there. I've got a coordinate at 91, so that one is going to be 1 lower. It's there. I've got a point at 180, 0. That's going to be 1 lower. It's going to be there. And then I've got a coordinate at 270 minus 1, so that's going to end up at 270 minus 2. And then finally I've got a coordinate at 360, 0. It's going to be 1 lower at 360 minus 1. So once I've got all my points, I can just join them up with a curve like that. A bit wobbly at the end. but let's see if I can draw that bit again. Okay, that's better. So that's my transformed curve. Right, what's the next one about? Okay, now this time I need to sketch the graph of y equals minus sine x. So if I've got a graph y, y equals f of x, and then it goes to y equals minus f of x, then this is a reflection in the x-axis. Okay, so that means every point on my reference graph y equals sine x is going to be reflected in the x-axis. So again, we're going to go through point at a time, and work out where all the image points are going to be. So 0, 0, it's on the mirror line, so that's going to end up in the same place. This point at 91, if I reflect it in the mirror line, which is the x-axis, it's going to end up down there. 180, 0 again is on the mirror line, so it stays where it is. 270 minus 1 is going to be reflected to the opposite side, up there. And then again, this one is going to be untouched because it's on the mirror line. So I've got all my reference points again now, so I can then join them up. Again, a bit wobbly at the end there. Let's just do that bit again. Okay. Happy with that? Looks okay. It's again a bit wobbly, but hey. Right, finally, on this graph, sketch the graph of y equals tan x. So basically we just need to remember what the tan curve looks like. So if you remember, the tan graph has a period of 180 degrees, and it has asymptotes at 90, and then also at every 180 degrees after that, so it's going to have another asymptote there at 270. Okay, it's going to go through 0, 0, and it's going to pass through 180, and it's going to pass through 360. So the curve basically goes up and approaches the asymptote there, kind of zooms around the universe and reappears down there, passing through 180, 0. Again, approaching that asymptote, around the universe and back again, reappearing down here, and then going back through. Question 24 has a graph of y equals f of x, which is clearly a quadratic curve, and we're told that it has a turning point at -1, -4. This point down here is the turning point, -1, -4. Now on the grid, draw the graph of y equals f of x minus 2. Now if you studied your transformations, you'll realize that that represents a translation of 2 units in the direction of x. So this is a translation of 2 units in the direction of x. So basically every point on my graph is going to move 2 units to the right. So this -4, -1, -4, this turning point is going to move to here. The intersect here is going to move 2 to the right there, and this intersect is going to move 2 to the right there. So I'm just going to have to draw another quadratic curve through those new points as best I can. Oh, and let's put those reference points on as well. So just try and follow the curve as best I can. Like that. It's a bit wonky at the end. Let's try that again. That's better. Okay, done. For part B, the graph of y is equal to -3x squared plus 4x minus 5 is reflected in the y-axis. give out the equation of the reflected line, give your answer in its simplest form. So a reflection in the y-axis is, again, if you know your transformations, is y is equal to f of x is transformed into y is equal to f of minus x. So basically we have to replace every x in that expression with a minus x. So we're going to get y is equal to minus 3 lots of minus x squared. So basically every place I see an x in here, I'm going to replace it with minus x. So minus 3 lots of minus x squared plus 4 lots of minus x minus 5. And then obviously I'm going to have to deal with all these negative signs. When I square negative x, I'm going to get positive x. So it's going to leave me with minus 3x squared. 4 times minus x is minus 4x and minus 5. Like that. That's my equation. Question 29. Here are sketches of two graphs. I've got graph A and I've got graph of y equals x squared minus 1. The graph of x squared minus 1 is translated 3 units to the left to give graph A. The equation of graph A can be written in the form y equals x squared plus bx plus c. Work out the values of b and c. So the graph of y equals x squared minus 1 is translated 3 units to the left to give graph A. Okay, so if I take a function f of x and I translate it 3 units to the left, that is equivalent of taking my value of x and adding 3 to each value. In other words, where I see x in my equation, I'm now going to have x plus 3 instead. So in the equation y equals x squared minus 1, I'm now going to have y equals x plus 3 all squared minus 1. So the equation then is y is equal to, so where I see x, I'm going to write x plus 3 for my translation of 3 units to the left. And the rest is the same. So x squared minus 1 becomes x plus 3 all squared minus 1. Okay, now I need to rewrite that in the form of ax squared plus bx plus c. In other words, I need to multiply out this bracket, so I can either double it up like that or remember the identity. A plus b all squared is equal to a squared plus 2ab plus b squared, which tends to be the way that I do it. I just remember that identity so I know what to do with these brackets when I multiply it out. So in other words, you get your first term squared, you get your two terms multiplied together and doubled, which is 6x, and then you get your last term squared, 9. So I get x squared plus 6x plus 9, and then I've got my minus 1 from before, which gives me x squared plus 6x plus 8. So comparing that with the form at the top, x squared plus bx plus c, so b is 6 then, and c is 8. Part B says the graph of y equals x squared minus 1 is reflected in the x-axis to give graph B. Work out the equation of graph B. Okay, so when we reflect in the x-axis, our equation f of x becomes minus f of x. Okay, so when you reflect in the x-axis, the y value will switch signs, won't it? So it's minus f of x. So work out the equation of graph B then. So if I take that equation, f of x equals x squared minus 1, and write a minus sign in front of it, then I'm going to get y is equal to minus x squared minus 1. So removing the brackets, I'm going to get y equals, it's going to be minus x squared minus 1, or 1 minus x squared. There's another way of writing it down. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.